accompanied by young members of the faculty management to inaugural lecture, Geospatial Application in Agriculture. Ladies and gentlemen, our national anthem Negaraku and Putra Gemilang. Ladies and gentlemen, you may now be seated. Assalamualaikum warahmatullahi wabarakatuh and good morning. Our distinguished guest of honor, yang berbahagia Professor Dr. Mohamed Iqbal Saripan, Deputy Vice Chancellor, Academic and International Representative Vice Chancellor of University Putra Malaysia, our gracious host, yang berbahagia Professor Dr. Nur Kamar Hanudin, Dean of Engineering Faculty, our honoured speaker yang berbahagia, Professor Surveyor, Geospecialist Dr. Abdul Rashid bin Mohamed Shariff, Chartered Engineer, Lecturer of Biological and Agriculture Engineering, who will be presenting his inaugural lecture, members of University Management, Tan Sri, Puan Sri, Dato, Datin, distinguished guests, families members of our speaker, ladies and gentlemen. To begin with, I would like to invite in Senior Dr. Muhammad Effendi Yaakob to recite the dua. Please welcome.
Bismillahirrahmanirrahim. Al-Fatiha. أعوذ بالله السميع العليم من الشيطان الرجيم بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على أشرف الأنبياء والمرسلين وعلى آله وصحبه أجمعين اللهم صل على سيدنا محمد الفاتح لما أغلق والخاتم لما سبق والناصر الحق بالحق والحادي إلى صراطك المستقيم وعلى آله وصحبه حق قدره ومقداره العظيم اللهم صل على سيدنا محمد وعلى آل سيدنا محمد وبارك وسلم. Segala puji-pujian bagi Allah, selawat dan salam ke atas junjungan besar Nabi Muhammad sallallahu alaihi wa alihi wa sahbihi wa baraka wasallam, semulia-mulia Nabi dan Rasul, dan juga ke atas kaum kerabat dan para sahabat radhiyallahu an. Ya Allah, Ya Fattah, Engkau berkatilah Majlis Syarahan Inaugural ini yang akan disampaikan yang berbahagia Profesor Dr. Abdul Rashid bin Mohamed Shariff. Kurniakanlah kerahmatan dan keberkatan serta kesejahteraan pada majlis ini yang kami anjurkan. Semoga syarahan ini memberikan manfaat kepada semua dan beroleh keredaan darimu, Ya Allah. Ya Fattah, Ya Alim, tetapkanlah iman kami, ikhlaskanlah niat kami dan usaha kami, teguhkanlah hati kami dengan kesabaran, luruskanlah tujuan hidup kami ini dengan kejujuran, agar dapat kami hulurkan tenaga dan bakti dengan penuh ketulusan untuk membangun dan membina universiti ke arah pencapaian yang cemerlang. Ya Allah, kurniakanlah kami dan barisan kepimpinan kami kesihatan yang berterusan, ketabahan dan kekuatan bagi meneruskan visi universiti sebagai universiti yang bereputasi antarabangsa. Ya Allah, Ya Fattah, Ya Alim, hiasilah diri kami dengan ilmu yang bermanfaat, ilmu yang membawa kepada keluhuran akhlak yang tinggi, ilmu yang boleh membangunkan potensi dan kecemerlangan yang berterusan. Kami memohon agar Engkau kurniakan dan limpahkan ke atas kami ini kesihatan yang berpanjangan, kekuatan mental dan fizikal, ketenangan serta kesejahteraan rohani dan jasmani, ketahanan diri dan emosi, ketinggian ilmu, keindahan akhlak serta kemuliaan peribadi, dan golongkanlah kami ini dalam kalangan golongan hamba-hamba-Mu yang soleh serta berkualiti lagi diberkati. Ya Allah, jadikanlah perhimpunan kami ini sebagai satu perhimpunan yang dirahmati dan perpisahan kami pula selepas ini sebagai perpisahan yang diberkati dan dilindungi. Sungguhnya kepada Engkau jualah tempat kami memohon pertolongan. Allahumma rabbana hablana min azwajina wa zurriyyatina qurrata a'yun waj'alna lil muttaqina imama. Allahumma barik lana fi Sya'ban wa ballighna Ramadan. Allahumma barik lana fi Sya'ban wa ballighna Ramadan. Allahumma barik lana fi Sya'ban wa ballighna Ramadan. Ya Allah, berkatilah kami dalam bulan yang rahmat ini, bulan Sya'ban, dan Kau sampaikanlah kami semua ke dalam bulan Ramadan. Allahumma rabbana zalamna anfusana wa illam taghfir lana wa tarhamna lanakunanna minal khasirin. Allahumma jam'ana hadza jam'an marhuma wa tafarraqana min ba'dihi tafarruqan ma'suma. Allahumma amin, Allahumma amin, Allahumma amin. Allahumma rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina azabannar. Wa sallallahu ala sayyidina Muhammad wa ala alihi wa sahbihi wa baraka wa sallam. Walhamdulillahi rabbil alamin. Wallahu minna wa minkum.
Amin, amin, ya Rabbal Alamin. Thank you, Insinyur Dr. Muhammad Effendi Yaakob. Ladies and gentlemen, let us use this opportunity to thank the mighty Allah for His blessing that we are able to be here today. It is hoped that through this event, we will able to get to know one another in much better way, gaining more experiences, and last but not least, to develop a strong networking relationship among us. Without further ado, we would like to invite our most distinguished guest, Yang berbahagia Profesor Dr. Mohamed Iqbal Saripan, Deputy Vice Chancellor Academic and International, to chair the event. Please give a warm round of applause.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. And very good morning to all of you. Thank you very much, Chairman. Yang bahagia Profesor Dr. Noka Mariah Nordin, Dean Fakulti of Engineering Universiti Putra Malaysia. Yang bahagia Profesor Surveyor Dr. Abdul Rashid, Mohamed Shariff. The most important individual today who's going to present his inaugural lecture. Senior officers of Universiti Putra Malaysia, management members of Faculty of Engineering, invited guests from the industries as well as from the agencies, family members, UPM staff and students, ladies and gentlemen. First of all, I would like to convey regards from Yang Bahagia Datin Paduka NAB Chancellor, Vice Chancellor, who's not been able with us this morning. She's now in Dubai, and I'm honored to be the person to introduce Yang Bahagia Professor Surveyor Geospecialist Dr. Abdul Rashid bin Mohamed Sharif in this auspicious occasion. Prof. Rashid was born in Ipoh, Perak. When I first knew him, I thought that he's from Pakistan. Not the first one, yeah, Prof? He graduated from University Technology Malaysia, UTM, in Kuala Lumpur that time, with a bachelor's degree in land surveying with honours in 1983 before he got his master's from University of East London, London, UK in 1990. Then he received his PhD from University of Maine in Maine, US in 1996. The first Malaysian to receive the degree in the area of Spatial Information Science and Engineering. Prof. Rashid has served Jabatan Ukur and Pemetaan Malaysia, JUPAM, and Kementerian Kemajuan Tanah dan Kementerian Kemajuan Tanah dan Kemajuan Wilayah, Ministry now known as Ministry of Water, Land and Natural Resources, for 16 years. Prof. Rashid joined the Department of Biological and Agriculture Engineering, Faculty of Engineering in 1999. And then he was promoted to Associate Professor in 2003. And then in 2018, he was being appointed as the professor. He has served as the head of department from 2001 to 2006 and as the head of Spatial Numerical Modeling Laboratory at the Institute of Advanced Technology, ITMA, from 2009 to 2012. He catalyzed the formation of Geospatial Research Center, a university-wide research center then, and served as its first head until 2013. Prof. Rashid has taught several courses, including Geonavigation Satellite Systems, Spatial Information Management, Land Information Management, and etc. He has also wrote the syllabi for several of these courses, including the Research Methodology course, which was then made compulsory for all engineering students, and now it was being made compulsory for all students that are taking Masters by Research as well as PhD. Prof. Rashid is well recognized in his area of expertise nationally and internationally. His research interest is in multidisciplinary area, includes precision agriculture, GIS, cadastre and land information management, remote sensing and near sensing. He has authored and co-authored 109 publications in journals. In addition to the journal publications, Prof. Rashid is also actively involved in intellectual properties. He currently he has 19 patents pending, which include filings in Thailand, Indonesia, Brazil, and he also has 2 patents been granted. Additionally, he has also got another 14 copyrights. Prof. Rashid has received financial support from during then MOSTI Brain Gain Program, Science Fund, as well as from the Ministry of Higher Education in the form of PRGS and LRGS grants, as well as support from Universiti Putra Malaysia. In addition, he has also received both support from several international organizations such as Japan's JAXA Alos Pulsar satellite project, which is valued at ringgit Malaysia 7.5 million. Canadian Radarsat satellite projects for imageries valued at 240,000 ringgit, as well as extra budgetary contribution from the Republic of Korea valued at USD 30,000. He was one of the consultants for the first national research project on precision farming for paddy. He was a member of National Committee that drafted the National Geospatial Master Plan and related policies. He has also served as a SIRIM appointed National Technical Committee member on Geographic Information or Geomatics, a member of the Intensive Diploma in Oil Palm Management and Technology, and a member of Space Applications for Environment. Prof. Rashid has been president of the Institution of Geospatial and Remote Sensing Malaysia since 2012, a fellow and life member of the same institute, a fellow and life member of Malaysian Society of Agriculture Engineers, a member of American Society of Agricultural and Biological Engineers, a chartered engineer registered with Institutions of Agriculture Engineers in UK, and a professional surveyor with the Royal Institutions of Surveyors Malaysia. He has been the coordinator of the very active MOU between Tsukuba University and UPM, and has been closely involved in the activities of the Asian Microsatellites project for the MOU with Hokkaido University. He has also catalyzed the formation of the Malaysian University Satellite Consortium, which was finalized this year. Prof. Rashid is the recipient of the numerous international awards, such as DUO Denmark Fellowship Award in 2005, Australian Endeavour Award in 2008, European Commission Erasmus Mundus Award with the University of Munster, Germany Fellowship in 2009. Prof. Rashid's work has received international recognition in several European countries and as well as USA, such as Diamond for the special category of Green Earth Award and Gold Award in the British Invention Show London, Gold Medal in Brussels Eureka, Gold Medal in INA Nuremberg, Germany, Silver Medal also in the same exhibition, Gold Medal in Geneva, and Bronze winner in Georgia, USA. He was the chairman and the chef de mission for 2001 of the Balangtara, that is the students' mini tractor design team that competed in the States and won the Best Teamwork Award and the runner-up for the team homepage design in 2001 International ASAE Quarter Scale Tractor Design Competition for students. He also won the Best Speaker Award in the 18th Asian Conference on Remote Sensing in 1997. And in 2018, he received the Top Research Scientist Malaysia Award, which was conferred by the Malaysian Prime Minister. It was no doubt, ladies and gentlemen, that Yang Bahagia Prof. Surveyor Geospatialist Dr. Abdul Rashid bin Mohamed Shariff has received and achieved excellence in academics and research, as well as professional involvement as written in the inaugural book. Without further delay, let us now listen to Yang Bahagia Prof. Rashid, his inaugural lecture entitled Geospatial Application in Agriculture. The floor is yours.
Can you guys hear me? At the back? Okay, very good. Assalamualaikum warahmatullahi wabarakatuh. And a very happy morning. Do you feel happy or you feel just good? That's nice to hear. Our distinguished guest of honor, Yang Berbahagia Professor Dr. Iqbal Saripan, Deputy Vice Chancellor Academic and Internationalization, UPM. You have been an inspiration to all our academics, to all our staff and students at UPM. We are so proud of your presence here today. Our gracious host, Yang Berbahagia Professor Dr. Nur Kamaria Nordin, Dean of Engineering Faculty. You have shown great compassion and you are seen as a motherly and love the Dean of the faculty. We are proud of you. Our ever hardworking department head, Associate Professor Dr. Siti Khairul Nizar Bejo. Thank you for all the support to lead to this ceremony today. Members of the university management, Datin, distinguished guests, all family members, all members of the secretariat, including the Dean's office, the KBP staff, COSCOM staff, and all others who worked so hard to make the event a success today. All my students who are here and who are not here but supporting me from wherever they are. Your hard work and dedication over the last 20 years led me to the stage here today. It was not just my doing. Oftentimes, even the Nobel laureate winner, they announced on the stage, it was those hard-working people in the labs working day and night that led to the Nobel Prize being awarded to a particular researcher. But the honor, the real honor, goes to all of the students who supported the researchers. Give them a big clap. And finally, ladies and gentlemen, I'm so honored that all of you are here today. It is a special day in my life. I will take the attendance sheet and frame it up for my souvenir. It's not always that I can get to see all my good friends and buddies and supporters and family all coming together on a memorable occasion like that. It is called an inaugural lecture, though it's close to my official retirement. So it makes extra special because I can share you the lifetime of my experience working in the university and even before that. So with that brief introduction, I will start the lecture now. So, okay, MC? Okay. So the title today is on geospatial applications in agriculture. Very soon, many of you, so geospatial. Don't worry, if some of you came to support me only, by the end of this lecture, you will learn some of these terminologies, okay? So there's nothing too complicated today. If there are some mathematical stuff or something like that, I will summarize the use of it, the benefit of it. So my research in agriculture engineering is primarily focused on creating applications for the agriculture sector. This includes the plantations, it includes the farmers, and the whole gamut of the industry. This is one particular area of my application. I also do work in other areas of geospatial information. For example, we work with the Institute of Aging from the time they were incorporated. We work with the environmental people, we work with the medical faculty, because the application of geospatial are tremendous. So there are many applications where people can fit in. So before we begin, I like to take a little sip. I'd like to ask you, why do you think you are here today? I know my uncle here, he said he come because he's supporting me, yeah? And many of the students, maybe you come here. Why do you come here, student? Can you tell me? Your lecturer forced you to come. Yeah, I thought so. But I tried to make it worthwhile for you to be here today. But then, you are in the university, you can be asked to come by the lecturer because they think you get educated. But why are you in the university? You come to look for the degree certification? Take your hand up. You want to get a bachelor degree, a master degree? Yeah, you're honest. Most students come to university looking for the piece of paper they call the degree. They think after they got the degree so grand. Because why? The parents want them to get a degree. Oftentimes they don't know why they are here. From kindergarten to standard 1, all follow the parents. Parents say, go to university, go study. Get the piece of paper. And after I graduate, I tell, Father, you happy? I got a degree. Yeah? But not many realize why they need to get the degree. So if you got the degree, just for degree, I think you have to go to the next step about the knowledge. Consider you're getting the knowledge. And that knowledge you get can make a big change, a big change, not to yourself only, to the society, to the country, to the people. And here we are. You, with this change, you become an important agent. Why? You are mostly from agriculture engineering, I believe. If you go today to the hospitals, you find many people not well. The primary cause of it, if you study in detail, it comes from the agriculture people. They feed them. Many people who got the good qualifications later on, they are encouraged, go become a lawyer, go become a doctor, go become this. Who takes up agriculture? Not so many people. Huh? Some really love it. Some got it already. Now, these are the people. You go to the ground. You go to the farm. That guy may not even know how to count. He doesn't even have the basic like standard 6 knowledge. He is in charge of farming. He knows if I put a particular chemical on my vegetable, they grow faster, they grow bigger. I give a certain injection to my chicken, they grow big and strong. And when I weigh it, I get more weight. I get more money. We don't blame them. They are not educated in this field. But society expects the cheapest price. And the cheapest labor goes there. And now you are in the chance, you are in the position to change this as agriculture engineers. You are educated people. If you do your job right, if a percentage of you become the good agents of change, you will transform the society. You will find that the doctors will not have so many jobs. The hospital will get smaller because people are healthy. People will be healthy because of you. Not simply because they take more vitamin tablets. That's the negative way to go. They did a research to find out where the old and healthy people live. For example, in Okinawa, in Sardinia, in Italy, they take all those people where people are more than 100 years old and living active life. Meaning active life means they go on the motorbike, they still ride the motorbike, they still can work, they still active life. They found in Okinawa and Italy and so on. And they study these people. They're eating the plant food, agriculture stuff. And they eat meat on the average 4 times a month. And you compare with Malaysia, pagi nasi lemak ayam, and lunch also or dinner also got ayam some more, I think. So these are some fundamental things I want to put in your heart, in your soul. You are not here just to get the degree, not just the knowledge. Beyond that, we want you to make Malaysia the better and healthier place. And you have the capacity to do that. If I have my way, I will advise the government, pay the highest salary to the agriculture people. When you pay the highest salary to the agriculture people, you get the very best in agriculture and you get the healthiest society. You get the strong country. The doctors don't have so many jobs, never mind, they also can join agriculture. Okay, the important point. So please bear in mind, you are also the generation, you young guys here and many of the people also so young, you will be the generation that will witness human landing on Mars. And human settlement set up on Mars. This is not just a dream or just a story. There's a young lady, her name is Alicia Carson. She's 18 years old now in America. And she is in training in NASA. And she's being trained to land in Mars in 2033. If the plan goes well, if it goes according to plan, she actually goes, she will spend 2 to 3 years on the planet Mars. Now, this is not the science fiction. This is actual scientific stuff. Oftentimes, my colleagues talk to me, they say, you are too much rocket scientist. But look, we can sit down and think this is a dream. But people are making this dream happen. Now, how are they going to live on Mars? They need food, They need agriculture engineers. And already people are working how to set up the settlement. Many of you have been to IOI City Mall, You see how big it is, So you imagine IOI City Mall with a glass on top, like a greenhouse. So all the all the gas inside will not leave. So the plan is to grow vegetables. Grow vegetables in such an environment. As the plants grow, they give out oxygen, right? So over time, oxygen will be there. And what happened next step? Hey, keep some chicken, huh? You Malaysian like chicken. So start of the food cycle. Have some chicken, have some vegetable, then life will begin. And some of you in the future, you or your children, definitely some of your grandchildren, you may even spend Hari Raya there in the future. So this is the direction of the world, and the scope of agriculture engineers is so tremendous in this respect. So don't just look at the lower level. Look high up. The humanity is depending on it. Earth cannot sustain all humans forever. So with that brief introduction, while you are here, I was asked to also talk about precision agriculture. This is currently the buzzword in agriculture. Everybody wants to know why we need to do the precision agriculture, what's so important about it. And I don't know, I find sometimes, I think you don't feel so well. Anybody got Panadol? You brought some Panadol? And some water? Now, I tell you something. If one person in this hall not feeling well, and we need to give medication, Panadol or water, to start off with, shall I give also to you, sir? Shall I also? You said no, huh? And you know. What happened in Malaysian agriculture? When they give the fertilizer or pesticide, give everybody. You imagine, I say, open him up, put the Panadol, open him up, put the Panadol. This is the agricultural practice in most parts of the world today. We want to know who is not well and only give that particular plant or particular tree the medication. If only the plant can speak, he tell you, please lah, I know you are PhD, don't give me some fertilizer, I got enough. You know, we did the test. I'll show you some afterwards. You know, some areas over-fertilized, too much fertilizer. You don't need it. Okay, some area too short, you are giving not enough. So if we do precision agriculture, we identify each tree and give each tree the right amount. And if the tree doesn't need it, don't give it to the tree. So it's the personal care, taking care of the tree personally. That is precision agriculture in a nutshell. Okay, you okay now, huh? Very good. Now, to be able to do precision agriculture, you need to identify the tree. Now, you guys got UPM got a metric card number, you got the IC number, you got the passport number, you have international student, or Malaysian also have it. So we can identify you. We have your record in the hospital, so we can give you specific treatment. But how about the plant? When we plant them, we never make a birth certificate of the plant, huh? And if you go to the oil palm plantation, thousands and thousands of palm trees, right? How do you know which one to give more, which one to give less? You need to create a passport for them. And so for a long time, farmers, if they have small plots of land, they know the plants. In fact, I was told, there's a farmer who grows flowers. Huh? He grows flowers. He told me, when he goes past his flowers every day, he found all nice and healthy. After several months, he found all the one at the end, they have always been very weak, always half alive. So he decided to go and walk past them every day as well. See, purposely he go. His office is just in front of the first row. So instead of just walking past the first row, he goes inside and walks to the last row as well. After a few weeks, those in the last row also become very healthy. This is what he told me. So I share this with you. This is personal care. If you talk to your students or you talk at your students, it makes a difference. Students, if the lecturer just come and talk at you or not talk with you, it makes a difference. So this is the personal care. So precision agriculture means taking care of each plant personally, taking an interest in each plant and their requirement. And when you go there, I believe your presence, your vibration, and Prof. Tunku Aizan is here. She's dealing with the elderly people. Also makes a big difference. Giving a lip service to the elderly and actually sitting down there and taking care of them. A big, big difference. So same concept translated into precision agriculture. So in a nutshell, you put the right application at the right place at the right time. Okay? And we can customize it for seed, fertilizer, water, and pesticide. And we can also get optimum crop yield and get the benefits of the, of the profit. And there will be reduction of environment, less wastage of chemicals. There will be there will be no more rats holiday island. You know what I mean by holiday island for the rats? Anyone knows? You go for holidays, huh? Sometimes you go on the island for holidays. Some years ago, we did a research project with the farmers in Sawah Sempadan near Tanjung Karang. And we actually did the first satellite imaging project for farming community for rice farming. Some colleagues told us, you must be crazy, you know. Farmers, what they know about satellite technology, what they know about images. So this was the pessimism at that time. But we were working on getting the information and giving the information to the farmers to act. But somebody told us, how about giving the image of each farm for each area, for each farmer, to the farmer himself. So we did that. We take the image for the particular farm, it's just a small farm, 1.2 hectare, give them the image. Another person gave them image. And they proudly display it on their wall. They like to be related to the modern technology, telling people, we are in the satellite area. I know, look, this is my farm. And they proudly tell their visitors, look at this plot. I thought my paddy field is level, but it's not. There are areas, suddenly you see islands of land. And this is where the rats make a living. The rats stay there. This is the holiday island for the rats. They go and eat the paddy and come and stay there. They must have a home somewhere. So these farmers, using this very basic knowledge, they level off that area the following season. And look, that simple exercise caused their yield to go up. You see, there's a simple use of the satellite technology to help the small farmer. And furthermore, the farmers are not alone. They have children. The children go to school. And the children now, if you give new technology to farmers, the children help the parents. I will show you an example, which now Dr. Nick Norasma built it, application software, which the children can help the fathers and mothers on planning better for their rice fields. So on the right here, we have some sprayer on UPM, is spraying the pesticide. Okay. Oh. And another one here to measure the electrical conductivity. So some basic concepts or components of precision agriculture. You will need remote sensing. You will need a global navigation satellite system. And you will need a geospatial or GIS information system. So this is a very basic concept of remote sensing. So you have the light from the sun coming down. This light hits a building or hits any object like a paved road or bare soil or grass or whatever, or water or forest. Then this light is reflected and picked up by the satellite. Okay? And this satellite later will transmit this data down to the earth. Just like you can see me and I can see you. There's light reflected from me going into your eyes. So the same principle apply here for the visible light. We will see there are also other sources of light. Okay, there will be also satellite, like this radar satellite, it goes over, it's transmitting energy, it's actively transmitting energy. If you go out, it may hit your head and reflect back, you know. So sometimes you go out too much, you get headache, don't blame the satellite. Huh? Okay, some of you not sleeping yet. Okay, another one, important consideration, the light that comes to you, you know, when you see the light outside, sometimes you see the rainbow light, the red color, blue color, all that. So you see white light here, but it's actually got many components. So there is an important component of light there, which is called NIR, near infrared. You cannot see it, but it exists. And also the red light. So what we do in agriculture, we take these two types of light, we created the index called NDVI. It's normalized difference vegetation index, NDVI. So NDVI is just the difference of the NIR minus the red, near infrared minus the red, and divided by the near infrared plus red. We'll be using a lot of NDVI later on in this work. Yeah, it's a very simple concept. Just take the difference divided by the total. And this NDVI, they can help you to assess, for example, the greenness. You can see here, this is satellite image taken just a few days ago over Malaysia. You can see with the NDVI, this is just NDVI value. They're all looking green. Okay? If the NDVI value is maximum, it goes to 1. Minimum, it goes towards 0. So most of East Malaysia and Malaysia is looking green at this scale. And look at Syria. Of course, Syria is in the Middle East. You don't expect it to look green. And there's a lot of area which is yellow, and a little bit area. Even this is not a dark green, but just a light green. And towards Turkey, maybe it is a little bit more green. So, of course, they have been undergoing a war for many years. So this is also one way we can assess how's the situation of a particular country. If they are at war, we take the NDVI. We study the NDVI of the image, we know the situation is not healthy in a particular country. So same for plants. Just taking the satellite image, get the NDVI value, we can know this plant healthy or sick. And this is another use of the remote sensing. Here we, we take the direction of the typhoon. It comes this way. We can monitor the movement of it, the direction it's going. Yeah? So the villages or the towns along the way can make the planning for evacuation. This is why you see, when the typhoon strikes countries like Japan or USA, very few casualties. It strikes sometimes countries like Bangladesh or Iran, high number of casualties, simply because such simple planning is not done. And even we are not far behind. You remember a few years ago, we had a terrible rain in monsoon in Kelantan. We had to send supplies, and even until today, I was told some of those people affected are still homeless. And so, while we talk about other countries, we were not so much affected. Our system is not really there today. Even today, we are not so much ready. So similar to something like Bangladesh. Only thing, they get typhoon more often. We don't get typhoon that often. So this is something to bear in mind. So remote sensing technology can focus this ahead of time. So next one is the GNSS. GNSS is quite simple one. You use it all the time. Most of you got handphones. Some of you came here using your navigator. You want to find the location. The handphone gets the signal for your location and gives you a place here. So a lot of people have GPS. GPS is just one of those systems. It's the American system, GPS. They have GLONASS from Russia. They have got Beidou from China, QZSS from Japan, and so on. Of course, Malaysia don't have its own GNSS, so we depend on signal from others. But imagine one day you want to go for some important function, or your military, our military is making maneuvering. What happened? Suddenly, those countries which have the control to the GNSS switch off the signal for Malaysia. Imagine you want to go to some kunduri, you didn't know the place, you'll get stuck. You said, nowadays you don't have the book, A to Z. Those days they have a map book called A to Z. You can use it. So we are that vulnerable. This is why many countries which can afford it, they will go have their own GNSS or alternative system. And this is one of the reasons why the Europeans set up the Galileo system. Earlier it was just GPS. The Europeans, they wanted even to have the system when you park your car or go through the toll, you don't have to stop. The satellite just picks up your signal, and end of the month you get a bill. This is your toll for this month. Now, they were wondering, if you do such a system, and the American decide to switch off the GPS, so you may bankrupt those companies that are doing this work. So because of this, there was a lot of motivation on the side to go for their own system, Galileo. At first, the American resisted it, but finally Europe got the way through, and today many countries have their own GNSS system. So basically, the next diagram gives you a very simple example how this works. So we have at least 4 satellites, okay, and one person standing here. So you get the signal from one satellite, from 2 satellites. You can get a triangle, right? And you get a signal from a 3rd satellite, and you get a 3rd triangle. You get a signal from another satellite, you get another triangle. So all of these satellites, we already know their coordinates or their position in space. We know it. It's in the almanac, because the people who launch it, they know the location they land up. Then we also know the speed of the signal sent down. So if you know the location, you know the speed, you can calculate also the distance from here. From speed and time, you know, from the time it's sent here, you know the speed of the signal and the time it takes to get down, you can calculate the distance. So if you can get the distance of all the 3 triangles, you can solve the triangle. This is how the GPS is working on your handphones. It's as simple as that, nothing complicated. Yeah? So as far as you're concerned, you got the coordinate. And sometimes the coordinates is out. Sometimes out by 10 meter or 15 meter. That's why sometimes in areas where you got a lot of buildings, you may miss the junction. Because the signal hit some building, then came to your phone. If the area is flat, you go straight, the signal come to your phone, you will not miss a junction. But in a very cramped areas like in Singapore or in Bukit Bintang area, oftentimes you will miss a junction because signal not coming directly to your receiver, they are being bounced off some building. Okay, and finally we have the GIS. This is the heart of the entire system. This system, it captures, it stores, it checks and displays the data related to the position on the Earth's surface. Basically, the GIS must have one important information, just one. That information is on your location. That's all. Location could be XYZ. What's your coordinate? That's all. You know, people take the land surveying degree, they spend 4 years, or 5 years sometime, just studying how to get the location. Just that. During my days, we used to go up the tallest building in the UTM campus in KL after Maghrib on Friday night, and you only come down at Subo, at the morning prayers on Saturday, whole night looking at the stars, okay? Observing the stars to get the direction or azimuth, and to get finally the coordinate. Those days, no GPS. Now, if we had GPS, we don't have to climb. But it helped us to get the fundamental knowledge. 4 years studying just to get the coordinate and then the direction. So important in the position fixing. So, but tell me, you sit here, do you have a location? Sometimes people get confused, Everyone wants to get location. Now, here we can get location directly. This is row number 1, column number 1, or seat number 1. There's a location, 1-1, 1-2, 1-3. So all of you in this room have got the location already. So only thing we call this the relative location. Only in this room is correct. You go out, you have no reference. But with the GPS, you can make absolute reference. So the thing that makes the GIS so powerful is the location. We attach attribute information, text information, let's say, where you are living, who you are, okay? Who you are, what do you do for a living, okay? What is your schedule? All attribute information. Are you not well? What medication you take? All of the text information. But that text information, without the location, is not so strong in GIS. Now we add the location information. What is the coordinate of his house? What's the coordinate of his workplace? Now look, if you log on to the system, we know, okay, he has left from the house to the office. We know he passed the toll gate. If we are hackers, we are robbers, we know what time to rob his house also. So this is the dangerous part of the GIS. When I was among the pioneers also to do the GIS masters. I was having my Viva. The external examiner, Ian Harley, was from Australia, Professor Ian Harley. The first question he asked me, young man or gentleman, why are you here? You are from Malaysia. Why you didn't go to Australia to take your masters? So I was very worried. He's the external examiner interviewing me in the Viva, so I must give him a good answer. You see, I must give him a good answer, otherwise he might. I was just worried. So I managed to tell him a nice story. He was okay. He was not angry with me. He was not going to Australia, but he was just curious. He told me something. The GIS is so powerful, but in the wrong hands, it can spell a disaster. And you have seen it happen nowadays. In the government's gone crazy. They can target people. There have been cases. Go to a particular street, all the houses are there, you target only certain people, a certain race or certain religion, lock up the gate, put the chain, burn those houses. This is what he meant. I was thinking what he was saying in 1989 during the Viva. This is what his fear was. In the wrong hands, the GIS can be a very disastrous tool. Yeah? So please remember that. If you are in charge of systems, then such data should not be easily released to people. It must be kept in high confidence level. Now, Aging Institute working on helping the elderly, they have done a survey. 70% of elderly people, they want to stay in their own house. They don't like to go to old folks' home. But they're also very vulnerable. If they're staying in their own house, sometimes they may fall, one. But they also may be having security issues. So in the City of London, if the elderly person pick up the phone, local council already know. That person pick up the phone. Can tell, I need help, they send the help directly. And such information is kept super confidential. only certain people in that the organization can have this, because in the wrong hands, there can be many security issues. So this issue of the setting up the GIS way back in 1987, there's this guy, Lord Chorley, they have a parliamentary commission of inquiry. Now, he says that the system is significant to spatial analysis, as it is the invention of the microscope and telescope to science. He's comparing. You imagine what microscope and telescope done to science. This is what GIS has done. You imagine what computers have done to economics. You imagine what printing press has done to information dissemination. This is the level at which GIS is placed. At the highest level, it can benefit such a large group. So it is the biggest step forward in the handling of geographic information since the invention of the map. So this beautiful report, done in 1987, and inspired many countries. Many of those advanced countries today, they utilize this finding to the maximum. For example, the UK, the US, and also over there, the information in the US, for example, virtually free. You can go to the Jabatan Uko in USA, you will get the data free except for the cost of your pen drive or your CD. They will not charge you for the data. And you see today, the major countries in the world who are leaders in technology, selling us software, are those countries that give the data free of charge to their citizen. What does it do to the citizen? It helps you to do your project. It helps you to think of new projects. You know, I hope your young people today can lobby the government. Please follow such good example. You know, so sometimes I read what they discuss in the Malaysian Parliament, some very good stuff. Sometimes I am so saddened if they reach this level, meaningful and useful discussion will propel our society very far ahead. Okay. So is everybody very clear about the importance of the location in the GIS? And all of you know these basic terms, like latitude, longitude, you know? Equator, you know? You know equator? It exists? Okay, some like that, some not so sure. Equator in Malay, they call Khatulistiwa. My best study in both English and Malay, so I'm comfortable with the geographic term also. Khatulistiwa. So a few hundred years ago, the British ship was coming down towards the equator. And the captain, he looks in the telescope. He looks, he looks for, then he looked at his chart, and he said, we are approaching the equator. And his assistant said, I want to see, sir. So he takes the telescope, captain gives it to him, he looks, sir, I cannot see the equator. The assistant couldn't see the equator. Then the captain took again and see, I see the equator. Then the assistant again took, and this time a strong wind blew, you know. And he looked, I see the equator. I see the black line. Then the captain was surprised. He took the telescope and he looked. He didn't see the black line, but he said, that's the equator, because the captain, he knows how to calculate and see. Then again, this guy, assistant, took it. I see again the black line, and I see a camel on it. You know what happened? The assistant, he had long black beard, you know. When the wind blew, the beard went in front of the telescope, and then the flea, the kutu, was traveling on the beard. So, now you never forget location and latitude. Okay. Now, next one. We are going to discuss about these things. Soil-based mapping, web-based GIS support system, land suitability evaluator, satellite image for oil pump nitrogen. We are going to study about the oil pump, FAB maturity management, automatic detector for counting backworm, looking for missing oil palm tree, and the application of satellite technology to monitor rice growth, and finally, how we can do cloud seeding better. This is the overview. So don't get too worried. As long as you understand the concept and the take-home message, you are fine. And also, at the end of this talk, there will be my email. You can later on request the full slides of this PowerPoint. Also, we will be putting up on some website. Okay, first of all, we are going to go to a neural network approach to GIS-based soil mapping. Just now, we talked about, I tell you the whole story first, then we look at the slide. I told you, we have to give the right prescription at the right place. Now, if you go to the agriculture land, how do you know which area to apply more fertilizer, which area not to apply fertilizer? You have to do some soil sampling. Most Malaysian small farmers, smallholders, they don't do any soil sampling. In America, they do soil sampling. For them, it's very cheap. For Malaysian, too expensive to do soil sampling. This is the reason why our farmers don't do soil sampling. So it's like if you're sick, you don't go to the doctor. If you don't go to the doctor, then how are you going to get cured? This is the analogy. So we try to find a way. Can we try to do soil sampling in a cheaper way? Okay? So, and if this type of method, then can it help the farmers? Then they can apply it onto their ground. So we look at some method here. Sorry. So we wanted to predict, So we wanted to predict the soil macronutrient, nitrogen, phosphorus, potassium, and so on, at the unmeasured locations, using something called ANN. ANN is artificial neural network. It is part of the artificial intelligence. Nowadays, this technology is very rampant. But when we started this, we were relatively new in the agriculture to bring this in. And we want to generate accurate soil map using a combination of actual sample and a predictive sample. So let's say one area is so large, you need 236 samples to cover the whole area. So what we did, we said, how about we take less sample and predict some sample first. And take lesser sample, predict some more sample first. Okay? And afterwards, we take those we actually survey and those we actually predicted, put them in the system, then create the soil fertilizer map. This is the first project. Yeah? Okay. So, so this is the study area in Tanjung Karang. And, okay. So we take 236 samples, then we also take 118, 59, and 30 samples respectively, and train them using the artificial neural network to generate the soil map. And this is the artificial neural network. Basically, it tries to mimic the human brain. We put in all the input, calculate all the possibilities, try to reduce the errors to the minimum, okay, so that your prediction shows the minimum error. Then we can try to use it to make a prediction. And when we study new areas, we put new information inside, it gets trained further. So in theory, with further usage, it gets better. Okay. So this one, what we did, we had the network, we trained with 118 samples, and we used to predict, when we predict another 118. So total up with 236. So same thing here. We take 59 sample, and then we predict 277 sample for unsampled location. This one is 277, we did not sample it, but we use it to predict. And same thing that we took 30 sample and predict 206. Then I show you the result we get after the analysis. Okay, this is the nitrogen comparison map. This is the map showing the 5 classes of nitrogen. That means you have to apply more nitrogen here and less nitrogen here in 5 different categories. So this is the map with the 236 sample. Okay, now compare this map with this one here, with 30 actual sample and 260 are virtual or imaginary sample which we calculated, sorry. So you look at the difference here. This area is still green, this area. That means if you follow this map, you're not going to make any mistake here, and here, and here, and here. Do you see the closeness of the two patterns? Can you not? Or it's not clear enough? Hamid, can you zoom in into this one? Maybe not so clear. Zoom in this one, and afterwards zoom in this one. That's right. Okay, look at this one first. This is 30 sample. To move a little bit to the left so that I can see this one. Oh, okay. And come down a bit. Oh, sorry. Okay. Okay, go up a little bit some more. Go up, not down. Up. Naik atas sikit. No, the same slide, on the same slide. On this slide, just go up a little bit. So that I can see the bottom here, so that I can see the bottom here. This one, little bit up. Yeah, little bit more. Okay, little bit, so I can see this one. I want to see this one. Can you go up a little bit? No? Yeah, okay, very good, very good. So can you guys compare this and this? This is 236 actual sample, and this is just with 30 sample. Okay. So we did this comparison. Even if you take less, at a 59 sample, actual sample, you compare 59 actual sample. So we will show you the result of this. Basically, it shows a relatively close match. Not perfect, of course. But if you talk about small farmer now not having any information, compare with them having some information. Okay, this is too much. Okay, so I take example here for a chart here. Using the can we go bigger again? Go bigger. Yeah, okay. So if you use the traditional method, you may get 60% accuracy with 59 sample. With our method, you're getting close to 80% accuracy. And same thing here. With the 30 sample, with old method, we are getting about 30%. With new method, we are getting more than 60%. So this is the significance of this research on trying to reduce the sample size, but using artificial neural network to maintain the accuracy or keep close to the accuracy. Okay, we move on now. So we did the same thing for phosphorus, and we did the same thing for potassium. And the good thing about this, this research work primarily done by now Dr. Ibrahim Jahanshuri and soon to be Dr. Sharzad. This work was actually patented. They have a patent for this. Members of the audience, I believe, are from agriculture department. We are very happy to share with this and for you to use in your particular fields as well. So next project we have is on web-based GIS decision support system. Let me have a sip first. Okay. Okay. So here what is happening? This is the web-based system, meaning that it's available on the internet, and it's a support system for the paddy. I tell you the story first. The farmers in Tanjung Karang, in many areas in Malaysia, they are left far behind in the computer technology. Okay, we have the GAH. Malaysia is so advanced in technology. At university, yes, but you go down to the ground, right to the people who need it. Farmers mostly nowadays they're getting adapted to the handphone, but for the computer technology, in terms of using it, application not so great. So also, rice is our security crop. Eating rice too much not good. All get diabetes and kencing manis. But it's still our security crop. And most Malaysian cannot live with the rice. And government give a lot of emphasis on rice. We're still importing almost 30% of our rice. So we focus on this project to try to help the farmers learn the latest technology so they can improve their productivity. So in this case, that time the student, now Dr. Nick Norasma, she's also here. She worked on this project for her master's. She created a web interface which can tell the farmer, if you go to this part of the plot here, this is how much fertilizer you need to apply. Okay, and she also created a module. You can give them information about different type of disease. If you see this type of coloration on your leaf, this is the type of pesticide you should do. And she also created a social media website in those days. So farmers can interact and share knowledge. This is the very advanced thinking at that time. Today, it can be further with simple apps. But certainly, the farmers then started to do it successfully. As I told you just now, the project that we used the satellite image and gave it to the farmers, this was the same project. Okay. So the main target groups here we had were the farmers themselves and also the farm managers, people who manage the farmers. Our study area was in Tanjung Karang. We have been there for many years now. We still have a team there. And this was actually part of the National Precision Farming Project for rice. And they had several components. They had the soil mapping, which was done by Department of Agriculture, and soil fertility mapping, which was done by UPM. They had yield mapping, advanced rice technology done by MARDI, then also remote sensing, satellite and airborne done by Remote Sensing Agency of Malaysia, water management, and then farm managers module, variable rate application, GIS analysis, nutrient management, integrated pest management. This is the precision farming first national program. And we are glad to announce UPM was part of this first project that pioneered and led to the formation, led to the eventual implementation of precision farming in Malaysian paddy fields. And we were working with the farmers. I read sometimes with a heavy heart, oftentimes in blogs, in social media, they say the UPM, or not UPM, they say university lecturers. And sometimes they don't use nice names also on lecturers and professors. Also they use agriculture names, but sometimes not nice to use that. So you can see from this presentation so far, and a few more slides I'm going to show you, the lecturers working with the farmers in the field, working with Department of Agriculture, working with the United Plantation representative is here, working with Nahrim also representative is here, with so many different people. All the pictures will show you this story. But professors, lecturers, they are not politicians. They don't go out to the newspaper and media and talk all these things all the time. They just confine themselves to their jobs. We just hope those guys in the blogs have a heart, come and understand the real issue. It is not simple matter. When you try to implement latest technology to the bottom 40, lowest group, least educated, that is the big challenge. It is easy for you to go to a super class factory, teach the engineers, no problem. Go to the lowest strata of society and try to make it happen. That is a big challenge. And I saw over the years, UPM lecturers did so much of that without asking very much. It's very challenging to do life science work. Sometimes you never get the results you want. So many factors change. You're waiting for the harvest to grow, you want to collect your data, the heavy rain come, all your yield gone. The worst example I've ever seen, one guy when he was studying in the USA, every day come back, very sad. Very sad, every day. For 2 years or 3 years he was sad. We said, why are you always sad? His cow not conceived, He's working on the embryo of the cow, but the cow doesn't conceive. So until the lembu beranak, his research cannot go on. So one day, finally, he came so happy. Oh, finally the cow conceived. He can get his experiment moving. He collected so much data. But then a couple of weeks later, again said, I think you guessed, the cow miscarried. So such is the danger, such is the challenges of life science research. So for those who are evaluating us, Prof. Iqbal at the DVC level, please try to understand the challenges of agriculture engineers. Not always they can produce so many papers because the papers take a long time to be produced. They need a lot of field work. I remember after I showed some work from Madam Vina, she was in the plantation in UP, and thanks to UP, you guys gave so much support. The snake went right in front of her. I think some of the students, maybe you quit the program. But no, even the animals, I'm surprised. I was also working in the field for a long time before I joined UPM, 18 years. And I am glad I did that. I saw the poorest of the poor in the villages. The children already left for the city. And it's too far for any support. They live very poor and not much help. And you want to access such place, you have to go on foot. Yeah. So, and also we surveyed the paddy field, we surveyed the oil palm plantation, we surveyed the irrigation canals. All of these actual experience in life is so important because it helps you to connect to your society. Not everybody have the luxury to sit in this type of hall with the aircon, and that's the part of the morning's job. Not everybody have this luxury. Most of them have to work very hard. I think the agriculture department people know it so well. You cannot organize a program for agriculture people. Come, this morning I'm giving you training. I say, Gilaga, I have to go and tend to my cows. I got to take care of my farms, So you have to work out a specific strategy. Even you organize kanduri in the kampong, they have to have a specific schedule. Not simply can organize like we do in the university. You have to find when everybody already tie up their cows, when everybody, is ready. So it may seem funny, It may seem funny, but that is the social structure they have there. So I urge all of you, if you have a chance, don't let it go. Go work with the people. Work with the problem. The problem is not going to be solved through some computer simulation or some solution in the lab. Never. It will only be solved if you go to the field and understand the real problem. I came across a professor in Japan, very unique guy. He tells his student, don't do literature review. All of you are trained that way. Must do literature review. Then only you do the methodology and He said, don't do literature review. I said, why do you say that? Prof? He said, his reasoning very simple. The people are doing literature review. They are writing journal papers. They have writing for 5-6 years, meaning that the problem is not solved. And one person writing on another person's review, another person's review, and another person's review, they are not solving the problem. They are solving their own problem of writing journal papers. They want to write papers. So they just continue. But he said, if you don't look at the review, close all the reviews, and think for yourself. Use your brain. Use your brain, find a solution. That was the challenge. So this is one of the reasons, oftentimes, Japanese come up with very creative solution people have not done before. Because they don't follow the norm. They think of a solution upfront, on top of their head. What is the solution for this problem? Okay? After you have proposed your solution, then you can see what others have done. This is one of the reasons. I go to Japan quite frequently. I'm amazed. Every time there's something different they are doing. They don't make much noise about it. Sometimes they don't write journal papers on it. But you see it reflected in the society. The latest one they're doing, 2020 is the Tokyo Olympics. Way back in 2014, they already started the move. They said, we are going to get so many visitors, and their diet is different, especially we are worried about Muslim countries. They only need halal food. So way back in 2014, Japan already started a big move to try to create more halal premises. That's why you go to Narita Airport today, you have halal shops for breakfast. I forgot, Terminal 2 or Terminal 3. You can have your breakfast there. It's all Japanese food, but halal certified. And there are people from Indonesia and Malaysia who go there and help them get the halal certification. So the Japanese are very obliging. You tell them, these are the criteria you have to have. You cannot have the pork in the kitchen, you cannot have this, you must clean, and so on. They just follow, and they got the halal certified. Okay? And another project they're doing, since the Olympics in 2020 they hook up the GNSS receivers to all the athletes. When they are training, they know how many kilometers they ran in this exercise. They know their heartbeat. All of this being measured and monitored. And I noticed last few years, Japan's sports going up in preparation for the Olympics. One of the professors from Kyoto University, he's heading this project on using the GNSS to measure the health status of the movement of these athletes. And same project we can try to do for elderly people in Malaysia. So that is for the Olympics. What about the elderly in Malaysia? Can we monitor them and then remotely somebody can check, oh, this guy's heart is going a bit weaker, Shall we send some support? Oh, this guy's pressure not good for so many weeks. Or this guy not moving every day at home. Every day at home. Why? Because they fly homebound. Can somebody send somebody with a wheelchair, take him to the Tesco or something, just to take a round? They do it in London. The local council, Majlis Perbandaran, they will send somebody, of course a trusted person, come Mohamed, come uncle, we take you. But you, okay, you can walk. But those who cannot walk, they take them out on the car, take them to the shopping, and on a wheelchair. Do you want to buy something, auntie? They buy it. Of course, auntie got to pay lah. But the point is that they are using the technology to the maximum to help the people. This is my point here. And same thing for here. Okay, so I told you already about the story about this just now. I just wanted to just run it a little bit more. Okay. Now this is all created by Dr. Nick Norasma. And then she created this Nick Norasma in the young days. So she went to the users with the farmers, get them to use it. Get the farmers to actually use and test the system. Because our agreement with Nick Norasma, if the farmers don't accept, we cannot pass you, You cannot just build a system in the university and say, oh, this is good. But get the farmers to use it. So this is her doing this testing here with the farmer here, and then also here. And the result was evaluation, and the graphical user interface was built. Okay. This is the web interface which the farmers could use or the children could use. It gives the schedule, What day the water will be coming into your farm. Okay? And then this is also pest and disease information. If you have such pattern on your stocks, what is the action to be taken? And what is the type of chemical to be applied? And the best part, she calculated out, if this one plot is 1.2 hectare, you can divide into 6 plots, I just use some markers here. So over here, we don't need any urea. You see, calculated negative 2.5 kilogram urea. Means no urea required. And here, 0 kilogram phosphate. No phosphate required. 0.16 kilogram potash. That's all you need here. And just like that, just now, we were going to give Panadol to all of you. This is what's happening. Many of the agriculture areas in Malaysia over-fertilize. After this project, another researcher, Dr. Imran, are you here, Imran? So he went into this area. I think for the next 1 or 2 seasons, he told the farmer, please don't apply fertilizer. Of course, farmers don't agree. Psychologically, they are already set, must apply. So Dr. Imran had told them, I pay you money for the yield. I already paid you, don't apply now. And they found out the yield was more compared to when they applied. Simply because there was excess fertilizer already in the field. Of course, after a few seasons, it will be depleted, then you apply. So this is the significance of research like this, you know. And it's so simple to implement because why? We don't expect the farmer here to have precise GPS. He just put what we say in Malay, pancang, or some ranging rods here, ranging poles. So he can divide his plot into 12 area, and he can stand in one small area, and with the normal fertilizer, they apply by hand, by wearing gloves, they just throw the fertilizer like that. So not all implementation of technology need to be super class. As long as you understand the principles of precision agriculture, you can bring it down to the farmer level. Okay, these some pictures that Nick Norasma put up here in the gallery. So whatever they do, they can share. They can create a social media among themselves. They can share the problem, a very good interaction group. And some of the results shown here. And this is me in the younger days. And some of the results came out. The people who were very satisfied and satisfied, you can see here, very satisfied were 3% and 69% were satisfied. So more than 72, there was 72 already satisfied. And here also we can see user satisfaction. The user satisfaction was here, green and blue. Green was blue, coming up to almost 70-odd%. And effectiveness of them in improving their paddy operation. Again, the effective and very effective, 60, 70, 74%. So means that it is well accepted. So in a conclusion, Nick Norasma helped to build a system that more than 70% of them are happy with this, and it can move the farmers and families into the IT era. This is important because we don't want to be left behind. We don't want them to be left behind. The children are getting involved. So my suggestion here to people looking for projects, you can work further on this one, okay? But use the apps, build new apps. Nowadays, more farmers using the handphone, okay? So that when they go to the field, they can easily collect this. And they can even take picture. Maybe UPM can set up the intelligence center. They take the picture, they just send by WhatsApp to the center. Center can advise them. Okay, I take another sip. Okay, next one we talk about the agriculture land suitability evaluator. So recently we heard some things about the oil palm. They are telling that now the people who have planted oil palm, please now remove some of the oil palm. You can plant bamboo, you know. It's a good crop, good value, you know. But and actually you do a test and find that the soil may be very suitable for bamboo as well. Bamboo has a good price as well. But the point is that people are planting without knowing exactly what is the land best for. What is the best crop to plant here? People don't have the information. Department of Agriculture did a very good job. They create some zoning maps to guide the farmers. Yeah, it's not very precise, but most of the farmers, they do not use such information. So the motivation for this research was, can we build a system? Can we build a system so that the farmers know, if I have this land, what's the best crop I can plant here? Shall I plant papaya here or plant pineapple here? Whatever. So this, and so to do that, we took all the factors, all the parameters necessary scientifically to determine which is the best crop. And then we brought those parameters into the GIS. Remember, GIS has the location. And we actually did the actual job in Terengganu, where the farmers didn't have a clue of what to plant. And sometimes you pity them. They plant, they don't get a good income, or they don't get a good yield, and so on. And after that, we did another project in Negeri Sembilan. I will share to you the result of these two projects. Yeah. These are all the parameters which we put into the system. Okay? And this was the first study area in Terengganu. Okay, we had this agricultural land suitability evaluator. You can select the crop, the climate, soil, topography, evaluate. So you put in all of this necessary information into your intelligent database, and also the climate information, nutrients, rooting condition, soil workability, oxygen, and so on. You put all of the information, and then we find out that the best areas for Terengganu, which can be planted with mango, are the green areas. And the worst areas are the red areas. These are the worst areas. And the good areas are the green areas. So we give this map. We hope the department in Terengganu, they can use such information then to advise the farmers. So in the future, if anybody wants to plant mangoes, go there. Go to these areas. So we can do the critical assessment of the available land evaluation. And we result in selection and development of a robust framework, and it suits the Malaysian agriculture requirement. Okay, so the system is implementation at the Ministry of Agriculture, indicates that the research has high potential to solve real-world problems. And this system we call Agricultural Land Suitability Evaluator, short form ALSE, for any piece of land to be evaluated for any kind of cultivation. The uniqueness of the system that it accepts unlimited number of crop. It allows the user to introduce new crop and even modify its requirement based on the particular environmental condition. So to do this project, Dr. Rania now, she's now a lecturer in the University of King Abdul Aziz in Jeddah. She's originally from Sudan. So she went actually with me to agriculture department. We talked to them over several sessions, made presentation to them. Why? We wanted to know the real problem. If you just open literature review, take parameter, make a computer model, very easy. Go to the ground, understand. They have much experience. They shared their experience with us. That's the beautiful part. You want to build an intelligent database, please talk to the people who can contribute the intelligence. Professors, university lecturers do not have that. It is with the users on the ground. And unfortunately, not many researchers go to that level on the ground. That is the challenge. And here it is a very important person. So this is Dr. Farida. She worked very closely with Rania on this project, giving great input. She was the head of the soil division at that time. She's retired now. But we won many gold medals with this project. We also got the most downloaded paper in the Elsevier Journal, Computers in Agriculture, from this paper. I believe it was because of the input we got from the ground. It made a realistic paper. And people all over the world are downloading it, even until now. Okay, so another person came to me, Mr. Joma, now Dr. Joma. He was having similar interests. So he started to investigate the same issue in the state of Negeri Sembilan, district of Seremban, to find out about area suitable to plant rubber. Okay, sorry. Okay, so we study in the Seremban district, and some of the data he used here is listed here. The soil map, terrain, land use, rainfall, drainage, land of dry season. And here is some of the land maps which he had to use. Rainfall, dry, wet months, soil series, and so on. So he had to input all of these maps into the system, and also other layers. And finally, he got the output map. Okay, so finally he got the map here to show which areas are most suitable. Jamit, can you zoom in this map? Just this map, yeah. Oh no, the next one, the next one. The next slide. Yeah, this map. Just zoom in. Yeah. Okay, bring it to the right-hand side. Okay, you guys at the back, can you see it? Yeah, very good. Now, the most suitable area is the green one. And where are the rubber tree planters? These are the rubber trees. Can you see the rubber trees here? Those are the rubber trees. They planted the rubber trees in the area not supposed to plant rubber tree. Not good for rubber tree. I want to ask you, if this is your land, is this the way you will plant? It's your land. Will you plant this way? If you know this area, not good for rubber, and this area very good for rubber. Okay? Very good for rubber. This very good for rubber. Didn't plant it there. If it's your land, will you do that? Hey, don't hear answer. Are you worried? No minus mark, huh? Okay. So, will you do that, Prof. Aziza? No, definitely not. Yeah, it's not your land, huh? So, what happened? They plant. Most of it was planted with oil palm. And you know the sad story of oil palm today. They did make the wrong choice. If they plant the rubber, the world demand for rubber going up, for globes going up, and there's a good crop for rubber. There's a good area for rubber. Also, there are other crops which are suitable over there. The thing is happening in Malaysia. We can do research in the university. The people on the ground, they don't follow our research result to plant a crop. They have a land grant. Huh? Normally on the grant, it's written down there. Your grant you can do for agriculture, or sometimes, even worse, it's written there, soil condition, rubber only, or oil palm only, something like that. This is controlled way down at the land office in the district. Policy, we can go and talk to the Minister of Agriculture. They have no control on what the farmer will do on the ground. They can advise. Now, the countries that become stable and powerful, they give agriculture a very, very important concern. I told you earlier, we put our lower strata to work in the field. One. Number two, in Israel, how they survive in such an environment? Why are they so advanced in the agriculture? So careful about water, so careful about crop. Even sometimes you are buying dates, they tell you that dates actually from Israel, huh? But they change the label and put Palestinian land or something like that. So these are factors. The country like Netherlands, small country. We got the former ambassador here also, huh? Dr. Fauzia. So maybe she can share experiences. They can export. Hey, look at the size of Netherlands. Huh? It's smaller than many of the states in Malaysia. They can export. Agriculture produce flowers, extra, they can export. So the reason is something like this. We got the land, siapa peduli what you plant. It should be our business. It should be the government policy. Because it affects all of us, not just the farmers. If they plant the right crop, farmer get increase in yield, fine. But it also affects you. If we do it positively, we get good yield for the whole country, government get good tax money. They are funding our university, they are funding your scholarships. So somewhere, for those who have the power, can you connect up with the decision makers? Can we correct this fundamental flaw in our system? Part of it got to do with our structure of federation. Okay, many people are amazed how Malaysia made it over from 1957 till now with all the federation. It works very well, huh? Federal government and state government. But when it comes to policy level, things like this, can we align? We have a National Land Council, but can we align the policy so that the important findings on the agriculture can flow down to the person who's going to implement it? Your agriculture will only be advanced as far as your farmers are advanced. You can go super duper in your Q1 publication, but your farmers are not advanced, your country's agriculture is going nowhere. You can double underline my words. Okay, this is the important thing. Earn a Dr. Joma his PhD, but make an important point. People can start opening up their eyes. We need to make a fundamental change. So, of course, there was given a patent and so on. Okay, time for another sip. So, Puan Rogaya is still here. Okay. So now we talked just now so much about mostly the GIS application. Now we will go to some of the remote sensing application. One of them is nowadays people like United Plantation, Chiba is here. They want to determine how much fertilizer to put for the oil palm trees. So they do foliar analysis. Huh? So how many trees you have to take to sample for 1 point? And how much area they cover? 10 hectares. So to fertilize 10 hectares, they go to 8 trees, cut the frond, we call them frond, like you can say leaf, huh? We cut it out. Then they send to the lab, they mash it up, they do mix them all up, mash it up, and they do the analysis, and then they apply the same fertilizer for the 10 hectares. Huh? Okay, so he's doing 10 hectares. Huh? Some of them do 40 hectares. Huh? Maybe he's scared I'm here, you don't want to say more. Huh? I don't know. So some of the plantation, 40 hectares, they take one sample. A few trees. This is what's happening on the ground. Simply because it's very time consuming and very expensive, yeah, to do the foliar analysis for all. So our approach here, we say, how about doing the satellite image? Okay, we take the satellite image. From the satellite image, we calculate how much nutrient this tree needs. Okay, and I will show you some of the results now. So we will look, by the way, the total field cost, it varies, about at least 30 to 40%. I say at least, of the field cost goes into just the fertilizer, purchase of fertilizer itself. Fertilizer suppliers are not happy with my research. Fertilizer companies don't like my research over here. Because if this research is successful, people reduce the fertilizer input. Okay, so the leaf sampling cost, it's estimated just at the minimally about 10.8 million. So we tried this one, and what we look into, we took the image from the satellite, and just now I told you about the NDVI, yeah? And NDVI here, maybe next one. Okay, so we took the satellite image, we calculated the NDVI. Okay, we also calculate another index called not OSAVI, SEVI. We calculated the index and many other indices, sorry, to look at where we can find a correlation between these indices and the actual nitrogen requirement. So our research, we found from these results, okay, we found 28 suitable vegetation indices, and we found the M-SEVI index has a relationship of 93%, 0.93, was the best VI. And we're using this index, we can calculate the fertilizer requirement to 77% accuracy. That's where we are. Meaning that using the satellite image today, we can tell the plantation or farmer at 77% accuracy how much fertilizer to put per tree. Per tree. Not for 40 hectares, not for 10 hectares. For each individual tree. So with this further funding, we can probably get it even lower down. I think for the industry, maybe 80 to 90% probably sufficient, because even the lab analysis is not 100% accurate. Okay, so now next topic I'm going to talk about is on the oil palm maturity classification. Dr. Aizam, are you here? No? Okay. Not Professor Tunku Aizan. There's one lady, Dr. Aizam. She's now an associate professor in UITM. So she started this story in 2001. Young lady came to my room, knocked my room. And my room always open. If I'm around, room's open. Okay. So she came in. She said, number one, I need support. She's the daughter of a Felda settler. And she was doing her master's by coursework, but needed to do the research. And I was a new lecturer, it was 1999 or 2000. I said, okay, let me think about it. I have not rejected any student who entered my room, asked me to be supervisor. Okay? So I have all students who were rejected by others come to my room, I still accept them. Seriously. So the student failed with other lecturer, come here, also I accept. Because I believe, I came here after 18 years working outside. You want to take the best student just to chop the certificate to give them. You take the person who needs the support, bringing them to the higher level. You contribute something, you did something, you achieved something. So I took her, and I asked the UPM that time, they were kind enough to give me the seed fund. They call seed money. I think 10,000 ringgit or something like that. And I bought that time a digital camera. was very bulky one, and her job was go to the oil palm, take the fruitlet, not the bunch. Oil palm, there's a bunch. On the bunch, they are fruitlet. Some people call seed, actually the fruitlet. Then take them and image them. Take images of them. And afterwards, press the fruitlet, take the oil out, and then compare. Can we correlate the value of that color in the image to the amount of oil you're getting from that fruitlet, in the fruitlet? That's all. She said, yeah. But she found not so easy, because you have to go do some chemical stuff, you got to work with MPOB. And I thank also that time Dr. Puan Rohaya and the team, also they supported this very well with the chemical analysis lab. So bottom line is that from this research, they found a correlation. They found a correlation between the oil content and the digital number. That was the first such discovery in the world, that you can actually determine how much oil in the fruitlet based on the color of the fruitlet. And I presented this in the MAP India in 2002 or 2003. Presenting in a conference in India is no joke. It's not like presenting in a conference in Malaysia or USA. Indian audience asked a lot of questions. So it was a good fun. It was good thrill. So, and also there was somebody from Australia. They were amazed that at that time we were able to find this relationship. I think I must thank partly to the interdisciplinary nature of the research, because we brought in the geospatial element, the remote sensing analysis method into the agriculture sector. Without this intermarriage, such project will not have realized its fruition at that time. We're talking about almost 19, 20 years ago. So we did that for the fruitlet. We thought, okay, so easy now, can we apply it to the bunch? Because at that time, some problems start to happen. Farmers are very angry with the FGV, at that time Felda, also with the mills. Farmers take their oil palm bunches to the mill. I want to sell to you, sir. Will you buy? You have the mill. What do you tell the farmer? Yeah, I will buy, but the price lower, not good grade, Farmer say, my grade very good. The mill say no. And the mill employ graders. Graders have a look. And graders look with the eyesight. They just look physically with the eyesight. And then they say, this is ripe or overripe or underripe. Now, if the graders are paid by the mill, are their decisions fair all the time? It's a question mark. It's a biased sort of scenario. So we thought, how about we try to take our research on the grading of the fruitlet to the bunches, okay? And that's how we started the next project here. And by the way, the government, FGV and so on, after some court cases, they ended up paying millions to those farmers in many FELDA schemes. They proved that the receipts that they got afterward, the oil squeeze out was much higher than the oil was paid for. They were getting, I think, 15% or so. They were paid 15% of the oil palm extraction, but they actually extracted 17 or 18%. So some very learned judges gave judgment in favor of the farmers. So this research became more important. So this is we took the fruit bunches here, okay, and this is called nigration. The oil palm bunches also have different varieties. So we imaged all of these bunches. Also we imaged the oleifera bunches, they're a little bit orange in color. We imaged the virescent bunches, and we built the first oil palm conveyor scanner. This is the conveyor. We built the first oil palm conveyor scanner in the world. And this scanner is still in our lab. We also took it to United Plantation to do some testing. Thank you very much for all the support. So we used this scanner, they tested in the United Plantation, and we collected all the data from here. And today, I'm happy to tell you, there's a company actually bought this patent from UPM to try to commercialize it. They are now they are trying out in some mills in Sarawak. Okay, so this is the user interface that comes along with the scanner. And over here, you can actually have a model based on the colors or the textures or the tones. You see, Dr. Mofta in Libya now, he developed this model for the color, the texture, or the tone. So we can actually image them, and then we can get results for the for the ripeness based on the using again the neural network, and we were able to get accuracies about 92 to 93% for this oil palm grading of the ripe, overripe, underripe. And one of the reasons we can get that is because the fruit goes through a compartment. The compartment is sealed. It blocks out the light. So it's just like the airport scanner. You go inside, so it's image there without the interference of external light. So it gives you a very good quality or color indicator of the fruit. And then the good part was that he got the 92%, 93%, he got his PhD. Now he's become a professor or the dean in his faculty in Libya. Okay, then next we work with another scanner. This is hyperspectral. Hyper just like a hypermarket, very big. So here, what is big is the spectral. We have here we have the range from 100 nanometer go up to 1,100 nanometer. There is many wavelengths go through that. And with all these waves going through the fruit, Osama bin Said Mohamed, not Osama bin Laden, Osama bin Said, he was the PhD researcher. Now, he came up with this graph. It's a critical bench in identifying maturity of oil palm. So between 400 nanometer and 1,000 nanometer, we can see that for the red one, this is overripe fruit, the green one is ripe, and then the blue one is underripe. Okay? Then at somewhere between 800 to 900 nanometer, you can see a difference between this. So you can get a different reflectance value over here. Okay? What it signifies is that if you use this particular wavelength and you get this reflectance, you can actually identify what category of fruit it is. At that time, Osama made this discovery. This was called the $1 million graph. Because nobody had the graph, and if people wanted this graph, they could make more than $1 million. Because they'll know, after so many years of research information, we can tell you which is the best wavelength. But we are researchers. First we publish a paper. Before that we patent. So we patented this, then we publish a paper. Now the whole world can try to work on this range of wavelength to build the different type of scanners. So after that, working with our collaborator from University of Florida, Professor Reza Aksani, we built the first multi-band optical sensor here, okay, in experimental mode, using the data or the information from the previous research, from the $1 million graph. Are you with me? Are you confused? Shall I go back to the earlier slide? Okay. Okay, the next technique, though, we keep on working on this. We came across a fluorescence sensor. We wanted to test whether we can find out the ripeness of the bunch using a fluorescence sensor. What is fluorescence? You shoot the light at a certain wavelength. It's 373 nanometer here. We shoot the light at 373 nanometer, and then the one that we collect back is at 447 nanometer. And another one at 735 nanometer, not 373. What is happening? This light at 373, it just not go on the fruit and go up. If it go to the fruit and reflect back, it is also 373. That's reflection light. We are not interested in that light. We were interested in the light that goes inside the fruit, then comes back out. That's what we were interested in. And we found it. We found this special band, also was a secret for a while. These two bands are so critical, they go inside and come out. And Mr. Hafiz, are you still here, Mr. Hafiz? So Mr. Hafiz worked on this project for his master's. He's now doing a PhD in the UK. Now, we are able to then use this to build a portable sensors to try to detect fluorescence. Fluorescence gives important activity because why? Fluorescent light goes into the fruit. You know, inside the fruit there is oil. There is also sometimes a reflection of the quality, for example, free fatty acid or other quality product. And then it comes back out. So we try to harness the reporting that will come back from the light that went inside. Okay. So using the information, we build another sensor. We build what we call the OPRI, the oil palm reflex sensor. So it has got so many lights you can see here. Okay, and so many detectors. So what we do, we shoot the lights at the fruit, and then with the reflected light, and then the fluorescent light comes back. we detect it hacked by European countries, many other outside agencies about our own chopping down of oil palm trees. That's the biomass being missing. So this type of research, we can calculate how much biomass we have. If in some state like Sarawak, they keep on cutting off the forest, and then they report we didn't cut. But the satellite images are making this report to the Western agencies. So do not always think when the West saying that you have cut so many trees, your forest is shrinking, they're lying. They may not be lying. Okay? You yourself can look at the images, you can make your own decision. Yeah? If afterwards, break time, you ask me, I can tell you more of this story. So this is the area that we now work with. And she did some trial pod. She managed to able to achieve an accuracy of 90% to predict the biomass using this microwave satellite ALOS Pulsar. She was the one who wrote the proposal to the JAXA in 2010 or 11, I forget, around that time. And the Japanese government reciprocated by giving us the satellite images from the microwave satellite. This is different from the imaging satellite. You get the wave that can go through the clouds, and then they give you the backscatter. And this can characterize the tree's condition. Even it can go through the canopy to the trunk of the tree, and the signal can even go to the ground, and even into the ground. Okay. Then we integrated. We have also a project of integration of UAV with stress detection to monitor the oil palm condition. Many people don't know. Today UAV became so popular, but in 2012, UPM, in collaboration with Florida University, we flew the first UAV in Malaysia. Was flown in the Time Dhabi. Mr. Zahlan is here. Please give him a big clap. So fortunately, Madam Vina, she had kept some of the images or videos which captured over UPM. I show you now. Can we play the next image? So here, this is our UPM plantation next to the stadium. I mean, let's play the image. Let's play the video. So you can see our beautiful plant, but please observe, do you see anything there? Do you see something a bit yellowish? Do you see something yellowish? So job of the manager to identify where the fronds are changing color. That means they are lacking in the nutrients. There is a deficiency in the nutrient. Over here, you see? This one. Also here. Also here. You can see that, there are different coloration, Here also. Here, mostly belly affected. Okay, so we went one step further. Then we try to use a type of lens we call a stress detection. There's some glasses you can wear. When you look at the plant, the green light is blocked out, so you only see the actual color of the leaf under stress. So we used this filter, put it on our camera, and flew over the plantation. Let's look at the next video. This one. We see the plants through a plant stress lens. Very healthy, and the dark one, if totally green, will be dark. So you can see the difference here also. So here. can see the color difference here. Through the stress glasses. Okay, so we analyzed those images, and what we found is that we have numbered the palms here, 1, 2, 15, 6, and so on. And we look at some of this here, 17, 18, and 20. Remember earlier in the lecture I told you about the NDVI. We found that we calculate the NDVI for all of these palms, the healthy ones, and then the not healthy one. The weakest ones were over here at the number 20 here. Look at the color here. Look at the color here. Okay, if you wear the stress lenses, you can actually physically see the stress. If you put it onto a camera, you can actually image it. And here is the one not so healthy as well. And here are better healthy ones. So this helps is in the management. So Dr. Vijay, no need for like old days, the manager used to stand behind the jeep, like that, and the jeep go through into the estate road. The job of the manager was look left and look right, look left and look right. Where are the fronds or leaves which are not healthy? So he will also miss the fronds from the top. I know in UV, they use the aeroplane to fly over. Even the big boss goes fly there. So now we have given a technique where you can actually just use a UAV flyover and you can get a good idea of the health of the crops. Okay. And I think it's about 5 minutes to 12. So what I'm going to do, I'm going to skip just one of these here. I think I mentioned to you. We have now an interesting application. We are working on the cloud seeding for the precision rainfall. And before that, we are doing also another one on predicting the yield for the paddy. Sorry, I didn't have that. I wanted to see the yield prediction. Okay, we have one project on predicting the paddy yield from satellite images done by currently being undertaken by Asha. So for large area, we can predict the yield of the paddy to almost 100% accuracy, whereby the difference is very small. It's 1.23 or like some 0.000, virtually a 0% difference. Also here, we have done two experiments there in Sawah Sempadan, and our PhD researcher finding out this excellent result. Using the microwave satellite, we can predict the yield of the paddy very accurately, which can be used for planning by the government. Okay, and finally, we have one application. You know, sometimes it rains here, sometimes it rains there. So sometimes it doesn't rain. So the meteorological department fly the aeroplanes and shoot those clouds, and sometimes still doesn't rain over the dam. It happened in Kedah. It flood the village, it floods the local area because they hit the cloud didn't go over the dam. Let's say the dam over here, but it rained over here. So what we are doing now, we are looking at the satellite data to see the movement of the cloud, location of the cloud, and the wind velocity and direction. And then finding out which cloud to seed at which time, so that when it drops, it will drop over the catchment area. This is what the one of our students, Nadira, she's working on that project now. Okay. 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 Okay, so far I think I will come and conclude now. I was thinking about 1:15. You know, yesterday we had discussion in the professors group. They say Azan today 1:15, so I thought we can go until there. But yeah, but some people thought that maybe not a good idea. So for those of you more interested, you can email me. We can have further discussion. But basically, we discussed here today, the soil sampling is an important strategy. So we can, if we let it happen, then the farmers, they will have the budget to use it. And we also introduced you the concept of ALSC. Always remember, if my land, how I will do it. It's just because every other people land or government interest, I don't care. But it affects you. Also, we told you about the web GIS. Oh, sorry. One more. Okay. We told you about the web-based support system for paddy planting. We believe this is a big avenue here for the apps to come in and many other types of apps. And also we told you about the measuring the map farm nutrients from space. This is going to be the future of the agriculture. We told you about the conveyor-based oil palm scanning, which can separate the fruit. I gave a talk on this in Colombia last year, and also about 3 years before that. They invited me. And the uptake is so good, because in Colombia, they're opening up many new mills. So when they're opening up new mills, they put in the new ideas. In Malaysia, sometimes, we have the old mills, they cannot incorporate the idea directly into the old mill, disrupt the operation. But when they're opening up a new mill, then they can include the new ideas and the new technology. Okay, then we also show you the portable FIB scanner. We can use it for the graders. And we show you the imaging technology to identify the bagworm. And we're looking at the agriculture 4.0, and the way to go is beyond that. So, but I have to highlight to you also, in relative terms, Malaysia is in a very difficult situation. We had our Tiongsa in 1999, our first imaging satellite. I took the students to, that time the receiver station was UKM. We downloaded images of Grand Canyon in the USA. You know, Malaysian satellite imaged the Grand Canyon of the USA and other features. And they processed and produced a nice image. I was so proud. Malaysia producing image over American area. Never. That was the first in our history. Students were so proud. And subsequently, we did have the Razak set. It was not a success. It was just an experimental nature. And after 1 year, got hit by the South Atlantic anomaly. So until now, we have no imaging satellite. Singapore have 5 or 6. Indonesia also about 5. Vietnam going towards 5. And our neighbor Thailand. So what's happening now? As we go into the agriculture 4.0, we find that we are getting left behind because we don't have a very important source of data. They say, yes, you can buy. Mind you, we just get data from JAXA. The value is about 7.5 million just for one student project. And we cannot ask them every day to go over our area. We can only get data based on the agreement. Now, if we have our own satellite, we can use it at our disposal for areas which we want to monitor. When there is a typhoon or something coming, we can evacuate people. There is a very strong case for us to have not one but several satellites. So I hope those who have the power, those who have the position, can you talk to the relevant people? This is something that will benefit the country. And also, we talk about the apps. Apps are something that young people very much like to do. I hope we can organize a national apps competition from UPM for agriculture. Every year, we get the input in. If there is interest for IG and so on, from Institute of Aging, then we get the apps. We can develop it part of the final year project, master's project, and put it in the market. It can also generate income, but that's not the main idea. The main idea is to have this in the hands of farmers who can use them for everyday decision making. So this is, I think, about my end of my lecture. Thank you so much for listening to me. Assalamu alaikum. Thank you very much. So timing is okay.
Thank you very much, Prof. Rashid. Well, you can see his passion. I was actually wondering whether I'm seeing an engineer or a politician. The content of his lecture is very informative to all of us, and it is a clear indication that Prof. Rashid and his team has been working so dedicatedly over the last maybe 10-20 years on geospatial and precision agriculture, as well as some specific applications of GIS, remote sensing, and etc. And I'm actually very happy when I look at the references, because I think we have got 1 or 2 papers together, myself and Prof. Rashid, and very happy to see my name there. Thank you very much, Prof. According to Prof. Rashid's lecture, I can highlight some interesting points. Number 1, as soil sampling can be down to a lower number of samples, cost can also be reduced. And there is a good reason now for us to promote good precision farming amongst all farmers in Malaysia. And with farmers not always certain what is the best crop to be planted, the Agriculture Land Suitability Evaluator ALSE, a UPM bond product, will be an excellent tool for us to be used. The use of IT amongst the paddy farmers is certainly welcome, and it will contribute towards the rise as our security crop. And I think Prof. Rashid also got a thing for gadgets and apps, and even in his conclusion just now, he mentioned about probably some activities that we can do at the university level and national level to increase the awareness of integration of IT with agriculture by maybe having a competition on agriculture apps. And he did mention about agriculture 4.0, which is now we look at that as the way forward for us to have a greater interaction between computer scientists, engineers, and agriculture engineers. And I guess this is why also at the university level we are currently doing some transformation of our governance to look at or to facilitate platforms for us to encourage our researchers to work in multidisciplinary environment. I would like to use this opportunity to again congratulate Prof. Rashid and his team for securing substantial financial research funds from both local and international organizations and agencies, which I do believe that has significantly helped him and his team a lot in to pursue the excellent academic endeavor. And again, thanks and congratulations to Prof. Rashid for your contribution in teaching, research, as well as professional services locally and internationally throughout your 20 years of service here in UPM. And I wish to see all of you in the next inaugural lecture. With that, thank you very much all. Assalamualaikum warahmatullahi ta'ala wabarakatuh.
Thank you Yang Berbahagia Professor Dr. Mohamed Iqbal Saripan for chairing the event, and thank you Yang Berbahagia Professor Surveyor Geospecialist Dr. Abdul Rashid bin Mohamed Shariff for delivering his lecture. Ladies and gentlemen, with that it marks the end of our session today. We would like to extend our heartfelt gratitude and appreciation to everyone with us today for the support and contribution in making this event a great success. On behalf of our organizing committee, I would like to invite Yang Berbahagia Professor Dr. Mohamed Iqbal Saripan and Faculty's Management to have a photography session and visit to mini exhibition and lunch at the foyer. Other distinguished guests, ladies and gentlemen, also can have your lunch at the foyer. For students, you may get your packed lunch nearby the lift area. With that, thank you, and we look forward to seeing you in our upcoming event. With that, wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.